Okay, let's start. So, hi everybody, thanks for coming. We're going to talk about what's new and what's next in Docker. And DockerCon was a month ago, so we made a lot of announcements. Who here was at DockerCon this year? Okay, not very many, so that's very good. I'm going to do a kind of recap of all the stuff that we announced there. Talking about what's new for developers, for operations, and talking a little bit about the open source projects. You might wonder why the title, the Tao of Docker. The reason is Docker starts to be many things for many people. And recently I went to give a talk in China at the Alibaba conference, and I've been reading a lot of books about Taoism recently. And I found some concepts in Taoism that explain really well what Docker is about. So, a little bit about myself. I'm a Java geek. I worked at lots of different companies. 10 years building platforms at Netscape, AOL, and Sun, and then 10 years doing developer relations at Google, VMware, Microsoft, and then I've been at Docker for 2 years and a half. I'm French, but I'm from California. And what's relevant there is at Google, I was part of the team who created developer relations for cloud. Then at VMware, it was about Cloud Foundry, platform as a service, open source with Spring as well. And then at Microsoft, it was Java and Linux on Azure. And very quickly, I started playing with Docker. And then I decided to join Docker, the company. So let's talk about the Tao of Docker. So Taoism is a Chinese philosophy that has lots of interesting concepts. There are two of them that I think are very relevant to explaining what Docker is about. And if you're not interested into reading the Tao Te Ching in the text, there's this great comic book version that's fun to read, and it's a good way to get into it. So the first one is it's called Wu Wei, and it's a Chinese concept that means effortless action. So it means action without action. And for what that means in the Docker context is one of the use cases that we've seen more and more especially in our enterprise users, is modernization of traditional applications using Docker. So what they do is that they take old applications, either in Java or .NET, who are sitting on VMs. Sometimes people don't even have the source code anymore. And what they do is that they use some tools to Dockerize them. So put them in a container, put that container into a registry, and then once it's in a registry, you can start to apply CI/CD and deploy that to a Docker platform or to a container platform, and then you can start to modernize your application. So we see lots of customers doing that, and that corresponds really well to that Wu Wei concept. The other concept that's interesting in Taoism is they call that Zheran. I'm not sure I pronounce it well. Or naturalness, which means following the way of the world instead of fighting against it. And you might wonder, what does it mean in computer science, following the way of the world? What that means is we're in an era where the mainstream architecture for server-side application is horizontal scalability. And the natural way of doing that is with what is called microservice architectures, with bounded context, container-based, stateless applications, and no coupling between different components. So that's what is called the cloud-native architecture model, and Docker is a very good platform for that too. The reason I'm using Taoism as a metaphor is that the way we've seen Docker used by customers, enterprises and developers, devs and ops, is both to modernize traditional applications without coding, as well as to create microservice applications using the container native way. An additional reading, for those who are into philosophy, there's this French philosopher called François Julien. He's inspired, or he's a specialist of Chinese thinking, and he wrote 2 books. One of them is translated in English. It's called Silent Transformations. and it's about the gradual process to transform things. And I think it applies really well to both enterprise transformations as well as transformation of IT systems in the enterprise. And the latest one is only in French. This one is called A Second Life. It's pretty applicable to giving a second life to your apps by modernizing them. So let's talk about trends. The kind of trend that brought Docker to adoption. The first one was Agile. So Agile started with XP in 1999. Today, everybody's doing it. I think the best characterization of it that I've seen is by Adrian Cockcroft from Netflix, who's now at AWS. He talks about lowering what he calls the MTBAMS, the mean time between ID and making stuff happen. So Agile is really about making developers more productive and reducing the risk on applications by having business owner in the loop at all times and having something that builds at all times so that you don't spend like 2 years planning for a system that will be obsolete when you ship it. So minimizing that time is what agility is about, and Docker is a pretty good tool for developers to do that. The second trend is DevOps. So DevOps is more recent. It's in the past 5-6 years. It's a cultural movement. It's inspired by agile methods, but brings the ops team into it. It's about people, processes, and tools. So not only about tools. So Docker is one of the tools that's useful in there, but it's also about people and processes. And the kind of practices that are in there are continuous delivery, infrastructure as code, cross-silo collaboration, working in small iteration, and having that feedback loop and measurement between what you put in production and the development cycle. So having that a quick feedback loop in there. But DevOps also has an economic angle to it, which is in 1999, if you were looking at how many sysadmins, how many machines a sysadmin would manage, in the Windows world where it was much less automated and more clicking, it was 5. In the Linux world, it was 50. Nowadays, in large-scale organizations that have completely automated things like Microsoft or for Azure or Google or Facebook, one sysadmin manages between 10 to 20,000 machines. And I expect this trend is going to start showing in the enterprise. And that has a real economic impact on the size of the teams. The factor is 2,000 there. There's a people and process aspects there that's very important. It's not only about adopting tools. There's also, you need to change your organization and the way your IT teams are working together. And Hank Cog from ING gave a very good talk at DockerCon Europe in 2015, talking about the people and process aspect, how they reorganize their whole IT department, asking everybody to become developers, asking people who work on infrastructure to do infrastructure as code, and to check that code into the source code repository. So that talk is really interesting. It talks more about the soft aspects that are very important to achieve transformation to adopt DevOps. So let's talk first about modernization of traditional apps. So what we build at Docker is a platform that lets developers build on their local machine, either traditional apps, microservices, or third-party, and then the result goes to a CI/CD pipeline. There it can be signed, and then there's Docker Trusted Registry, which has a lot of enterprise features, role-based access control, customizable pipeline for going to production, and then universal control plane. All that is part of Docker Enterprise Edition. Universal control plane that lets you manage your containers either on-premise, on bare metal or virtualization, or in any cloud provider. So that's what we're building. Our customers, their priorities are portability. So that's one of the top priority for enterprise IT. And we've seen that that move of enterprises to the cloud. I remember I started talking about like cloud platforms at Google maybe in 2008, 2009 when we released Google App Engine. I remember going to talk to potential corporate customers at that time, and they told me, no way, we're going to put all all our code and data and applications in your platform, because there's no way we can run it on-prem or in another cloud. So portability now, so we're 8 years later now. Today, most enterprises have a cloud strategy, and they're planning to use potentially several cloud providers. So they want multi-cloud, and they also want hybrid, which means that there are some workloads that they're going to run on-premise. And so they want a layer that gives them that portability for their applications and data. The second priority is agility. So lots of enterprises have adopted the agile model, but still not to the maximum, and there's lots of work to be done there. And now that software is embedded into more and more aspects of any kind of businesses, like the productivity of software developers is becoming very important for many type of enterprises. And the last one is security. I'm sure all of you have heard about the Equifax debacle in the US a few months ago. There was one at Target a few years ago. Security issues for critical data for enterprises can make or break a CEO. And so security is one of the top-of-mind aspects that CIOs have in mind. And then the last aspect is the innovation challenge. So in typical IT departments, 80% of the budget is taken by maintenance of existing applications, and you can see a list of the market share for different operating systems going back to Windows Server 2003. So anybody has any workloads running on Windows Server 2003 here? Yeah, a few. 2008 maybe. Okay, not that many. So there are lots of old applications running on old infrastructures in companies, and most IT departments spend 80% of their budget on that, and they only have 20% on innovation. And the business side of companies is asking them to start innovating more. So how do you liberate some margins to innovate? So that's where the modernization of traditional application move comes from. Many companies are starting to take their old applications and modernizing them. And the savings that they get out of that, they use that to do innovation. And so we created a program at Docker called the Modernise Traditional Application Program. It's a program that mixes a consulting partner with Docker Enterprise Edition. So we provide a license for free for, I think, for 1 month. Consulting partners, they provide free consulting for a month. And then there's a partner for infrastructure that provides free infrastructure for a month. And the consultants come at the company for 5 days on premise. They migrate the workloads and they containerize them. Then they deploy that on Docker EE on that modern infrastructure. And then they measure, and the hope is that the measurement of savings will entice companies to just continue doing more of that. So we have a lot of partners in that program. Microsoft Azure is one of our infrastructure partner, and Avanade for consulting. We have Cisco and HPE on the infrastructure side, and Accenture on the consulting side. So the kind of impact that we saw is that basically these MTA program, because containers are much more dense, allows you to pack more workloads onto the same hardware. Even when you're using virtualization, it reduces cost by 50%. And so usually after one of these proof of concept, people just start doing more of that. And so the way it works, we take existing applications, we have some tools that our consultants are using. So we had a demo at DockerCon of this tool, the Docker Application Converter, that can take either an archive of your application or a VM image, either a VHD or a VMware image. And then it converts that application into a container that you can then push to a registry, and then you can deploy that to a Docker Enterprise Edition, and you can set that up into a CI/CD, and then you can start to modernize and break the monolith into different services. or not break it, but add microservices to add value to the application. So that's the big difference with other approaches, is that the other approaches that force you to recode all your application in cloud native, typically there's a lot of time and effort before you see any value. And then one day when you have finally refactored all your application into microservices, you can finally deploy it and you get the value. The Docker MTA move is much more gradual. And that you can get the value right away. And then as you start breaking the monolith and adding more microservices to it, you'll add more business value to existing applications. So at DockerCon, we had one customer, FinishRail, who presented how they did their move with a cost savings of 50%. We had MetLife, who saved like 70% on their VMs, and I think they migrated 590 applications. And one of the big announcements was that we have a new partner both for infrastructure and consulting in that MTA program. It's IBM. So we had a collaboration with IBM for many years, a lot in the open source and in bringing Docker to P and Z architectures. But they're also contributing to OCI and to Containerd and lots of other projects. And now what we announced is that there will be a version of Docker Enterprise Edition running on mainframe. No, so not on mainframe. It's running on mainframe already, running on IBM Cloud. And the IBM Global Services is going to do MTA proof of concepts for customers. So Docker had lots of adoption by enterprises. They're doing all sorts of things with it. But the two main use cases are MTA or cloud native applications. So now let's talk about the platform itself. So Docker as a platform for cloud native applications. If you look at the platform itself, it's really a layer that sits on top of your infrastructure and under your applications that provide a single API for developers and operators that doesn't change. So your infrastructure may change. There may be some new cloud providers, new type of resources like GPUs, or maybe new type of devices that appear. Docker tries to run on each of them and will adapt to them and offer you the same level of APIs for you to build your applications. Also, when there's new type of applications that are created, they should be able to run on the same platform. So the principles of the Docker platform are independence. So that's what I was talking about portability. So it should be independent from the infrastructure and from the application. Openness, so Docker should adapt to your existing environment. There are versions of Docker Enterprise Edition that are running on either cloud providers directly or different Linux distributions. It should be able to run on Raspberry Pi and different things. And it should adapt to the existing systems that you have for logging, monitoring, and all that. So we have a system of APIs for that. And then the last principle, what made Docker very successful, is simplicity. Containers existed since many years, but they were really hard to use. And Docker made them very popular by providing a simple API for everybody to be able to use them. So let's take a look inside of the platform. At the bottom layer, we have the container runtime. So at Docker, it's called Containerd. So Containerd is a project that evolved with time that contains the core container runtime of Docker that is responsible for creating containers and managing images. So that's a project that we donated to CNCF, and it's nearing a 1.0 right now. I think it's in 1.0 beta right now. On top of that, you have an orchestration layer. So at Docker, we're using a project called Swarm that provides us orchestration with lots of different features, especially in the area of security, like mutual TLS for every node in the cluster, and secure secrets management, and lots of other features. And it allows us to iterate very quickly. And then we have Docker Community Edition on top of that. So that's the developer tools that developers are using to build and test their applications. So this is where you find Docker push and pull, Docker build, Docker run, and things like that. And then on top of that, we're a for-profit company, so we built Docker Enterprise Edition that is targeted towards operators in the enterprise, and this is a set of management services that you use to put Docker workloads in production. So we use a very well-defined process for improving the platform, and for that we leverage the strongest form of energy in the IT industry, which is constructive user feedback. So we get lots of feedback from all our users about Docker. This doesn't work, this should work this way, and all that. We improve the platform based on that feedback, and then we repeat that forever. And when we do that, we hear about patterns that emerge. And one pattern that emerged over the last year is about orchestration. And one of and that pattern was that not everybody uses Swarm. So there are lots of users who are using other orchestrators. Kubernetes, for example, is very popular. And it puts enterprises who choose Docker Enterprise, for example, in a difficult position where they have to choose whether to use the full aspect of Docker platform, the full benefits of it, or choose their favorite orchestrator. So the big announcement we made at DockerCon is that we added Kubernetes as an orchestration option in Docker. So now the platform looks something like that. There's Docker Enterprise Edition at the top, which is the best enterprise container security and management layer. Then Docker Community Edition. This is the tool that all developers are using to develop container-based app. And then there's Kubernetes and Swarm in it. And so there's native Kubernetes integration, which means that any of the tools in the Kubernetes ecosystem work with Docker now. And it's all relying on Containerd. And then between Kubernetes and Containerd, there's this open source project called CRI Containerd, which is the implementation of the container runtime interface that the Kubernetes project defined last year in terms of Containerd instead of Docker. And so at DockerCon, we had Brendan Burns, one of the founders of the Kubernetes project, on stage. And one of the aspects that was very clear to the Docker team is that the Kubernetes community and the Docker community are very close. We're one big community. And Brendan told the story about how he had the idea for Kubernetes coming back from the first Docker meetup in Seattle. So they did this pretty fun selfie with Brendan and Tim from Google at DockerCon last month. Okay, so what does it mean for developers? So when you're a developer and you're using Docker for Mac or Docker for Windows, if you're developing an application like a multi-service application, you're using Docker Compose. When you know that you're going to deploy it on Swarm, when you're testing it on your local machine, you can do a Docker stack deploy, and you can test locally on Swarm because Docker has built-in Swarm, and you can do a Docker Swarm in it, and you have a swarm of one running on your Mac or Windows. And then you can deploy to production to Swarm. When you were developing that application for Kubernetes, it was more complicated. You needed to first install Kubernetes on your local machine. There are lots of open source projects to do that, but it's not fully integrated. Taking compose files and deploying them to Kubernetes, there are some tools to do that, but you need to assemble several tools for that, and it's not very convenient. Now, with Kubernetes as part of Docker, so Docker Community Edition for Mac and Windows will get Kubernetes inside. So when you install it, it will just be there. We installed kubectl, the Kubernetes command line client as well. It's all configured, and you can start developing with that. And I'm just going to, and you can try both with Swarm or with Kubernetes. It's a choice that you make. I'm just going to show you how it works. So let me see. So here, let me make that bigger. Yeah, so here I have an application with a Docker Compose file. So it's an application that my friend David Gageot did, and it's a simple application that generates some fun words, and the characteristics of it is the more you scale it, the more funny the sentences it creates are. So it's composed of a front-end web service that's called Web. That's an Nginx. Then there's a backend with a dispatcher. That's a Go program that is dispatching it to a backend. And the backends are words, so they are Java programs. It's a program in Java. We have 5 replicas in there for them, and then the database is MongoDB in there, and there's some configuration options in there. So the way I'm doing that with my regular Docker workflow is that I'm going to do a Docker Compose build. And so Docker Compose build is just going to build all the images on the local Docker daemon that I'm using. Now that I've built my service, I can do a Docker stack deploy. I'm going to call it demo, and I'm going to pass it the compose file. And this is going to create my stack. It's going to create all the different services and create 5 replicas for the word service. And then I'll be able to, so the word service has at least 1 container running now. The backend is up, MongoDB is up, and when I'm done, I can start testing my application in there. If I go to localhost, boom. So this is my application, and it's running. And you can see the backends that provide some words. And here you can see the IP address of each of the backends. So these are the words, the 5 backend services. So my application is working. Let's take a look at the logs. So I do a Docker stack logs on that stack, and I can see the logs of all the different services, color-coded by service. So it seems everything's going well there. And there I can do a Docker stack PS of demo to see the different, Docker stack PS. And here I'm seeing all my services that are running and all that. So that's my usual Docker workflow to test an application with Docker Compose and Docker Stack Deploy. What I didn't tell you though is actually what I was doing there. It's actually running on top of Kubernetes. I was not targeting Docker. I was targeting Kubernetes. So what our team has done is that it has extended the Kubernetes API to create the stack object. And if you're using an environment variable to say, I want to deploy my app to Kubernetes, when I do a Docker stack deploy, it's actually going to talk to the Kubernetes API. We created that CRD in the Kubernetes API that implements the stack object, and then that CRD is just creating some Kubernetes deployments, so Kubernetes pods, load balancers, services, etc. So if I do a kubectl get node, you can see here that I have a local Kubernetes cluster that's coming with Docker for Mac. So I'm running a special version here that's not available yet. It's version 1709 Kubernetes experimental. So that's a build from a few weeks ago. And it comes with a Kubernetes cluster all set up for you running inside. And so when I do a kubectl get all, there you can see that my words application actually has been converted to deployments there for back, front, Mongo, and words. And that there are some pods that are running in there, and then some services for each of them. So that concludes the demo. Basically, today, when you're developing an application that is targeted at Kubernetes in production, you can test it in Kubernetes on your Mac or Windows. So that's for developers. Now talking about ops, Docker Enterprise Edition will also have Kubernetes included. And that means it's 100% interoperability with all the Kubernetes ecosystem. So it's Kubernetes 1.8 coming straight from upstream. Then the Kubernetes that comes with it will benefit from all the features that Docker Enterprise Edition has. Like, for example, the secure cluster lifecycle. Like the fact that by default, when you provision Docker Enterprise Edition with Swarm, it's very easy to set up a highly available Swarm with 3 or 5 masters. So these masters will also be Kubernetes masters. And the cryptographic node identity that we're using to provide a mutual TLS between the different services, it's also available to the Kubernetes masters. The secure supply chain features that we have in Docker Enterprise Edition, the fact that we have a Docker Content Trust in Docker Trusted Registry, the security scanning systems that we have, all the image promotion pipeline that you can set up, it works both with Swarm and Kubernetes. The secure multi-tenancy, all the role-based access control, LDAP integration, the node segmentation, that works with both, and the management dashboard exposes both Swarm and Kubernetes object, and you can watch the demo of the day 1 keynote. We had a 10-minute demo of all the features of Docker Enterprise Edition with the Kubernetes features. There's the Swarm objects, the Kubernetes object, and then some shared objects that work in both. And then all this is supported and certified on Windows Server and all major Linux distributions. So Docker is now powered by Swarm and Kubernetes. That was kind of the big news at DockerCon. Now I'd like to talk a little bit about the open source project. So the Docker innovation model is really based on open source. So we start with a set of components in the Moby projects. That's a project that we introduced back in Austin in April at DockerCon Austin. So Moby project has been very successful over the past few months. And the Moby projects contain the Moby/Moby project, which is the upstream for Docker, but also all the different component projects that we then assemble into Docker Community Edition for developers and Docker Enterprise Edition for enterprise. There's like 9,000 contributors to all these projects and 8,000 PRs per year. It's a very active set of projects. The different components are the things that we're using to assemble Docker. So Containerd is the core container runtime. LinuxKit is the kit that allows you to create Linux distributions that are based on containers that we're using in our edition, that we're using on Docker for Mac and Docker for Windows. InfraKit is a toolkit for declarative infrastructure that we're using in some of our editions. SwarmKit is the base of our orchestration engine. runc, the Open Container Initiative project, it's the reference implementation of the OCI spec, and it's used by Containerd to create containers. Notary, so two of these projects, Notary and Containerd, we donated them to the Cloud Native Foundation, and there are a lot of others in there. So lots of people were surprised by the fact that Docker was adopting Kubernetes. If you're actually following our open source projects, you shouldn't be surprised because we've been working on that in the open for a year. So it started back in November where we had a meeting at KubeCon with Kubernetes maintainers, and they gave us the specification for what would be an ideal runtime for Kubernetes once they had defined the CRI interface. And these requirements were really what drove the Containerd 1.0 effort. And that is in 1.0 beta right now. So then we had Containerd contributed to CNCF in March. In April, we did some demo of LinuxKit plus Kubernetes at DockerCon and Kubernetes and CRI Containerd at the Moby Summit. In September, at the Open Source Conference in Los Angeles, we did libnetwork and CNI demo. So what this is Docker has its own model called CNM for networking. And then you can write some CNM drivers that will allow your networking system to be plugged into Docker. What we did there is that we implemented a layer that provides a CNI interface. So that's the networking interface that Kubernetes requires for libnetwork drivers. So that means that all the libnetwork drivers become compatible with Kubernetes. Then we submitted Notary to CNCF in October, and then last month we showed the beta of Docker with Kubernetes support, what I just demoed. So what happens when the two largest open source container projects collaborate between Moby, the Moby project and Kubernetes? There will be a lot of fun projects and lots of innovation in the next year, I expect. And there's a whole community behind it. Lots of developers from many different companies have participated into that. So a few important ones. So Brandon, who created Kubernetes, Tim Hawkin, and Lantao Liu, their teams at Google worked with us on CRI Containerd. CRI Containerd is the CRI implementation using Containerd instead of Docker. It's in alpha release right now for Kubernetes 1.8. I think they're shooting for a beta in the next 3 months, and then I don't know when the GA will be. Containerd itself, there's a PR in Docker so that it will be Containerd 1.0 will replace the runtime in Docker itself. I don't know if it's been merged yet. And then there's Ilya, who's been working with us on the LinuxKit Kubernetes integration. Justin on LinuxKit. So there are lots of developers who participated in that. One other big change that happened in the Moby project is we still had our governance for the project had what is called a BDFL, a Benevolent Dictator for Life. So that's a title that a fun title that was created for Guido van Rossum for the Python project. And essentially it means that all the conflicts would be escalated to Solomon, who would have the final say. And we moved out from that model to move towards a technical steering committee that will be elected by the different projects. So that move is happening right now. I think the elections are held right now for that TSC. And then we had a Moby Summit in Copenhagen, 3 weeks ago. And that was super successful. We were expecting... Like we had a room for 420 people and we had 600 people registering. We need to make it bigger the next time. There's been lots of content about all these different projects during the Moby Summit. We have a blog for Moby, blog.mobyproject.org. If you're interested in the different components, we're going to post a recap of all the talks at Moby Summit, and they've all been recorded. So you have all the slides and the recording in there. Some of the highlights for me is it covered all the aspects of container systems from the classic compute, networking, and storage to like new kind of usages. There were 3 talks about serverless frameworks. So one by the Oracle team with FN, one by Alex Ellis with OpenFaaS, and one by Phil Estes from IBM about OpenWhisk. So all these frameworks typically run on top of either Docker or Kubernetes or both. There were talks also about a new component that's called BuildKit that's very important. We're trying to refactor the way Docker build is working. And BuildKit is a very flexible component that sits in the middle that's going to do the build. The Docker file will be one of the front ends for it, but you can create new ones for it. And also, Docker images are going to be one of the targets for it, but you can create different targets. So you could use BuildKit to build Linux packages or VM images or whatever you need, or unikernels. Another really interesting one was the one from the Balena team. So Balena is a new project in the IoT space, where what they did is that they took Containerd and they changed the way that images are fetched in order to use rsync to make sure that they don't that they get only the diffs of what has changed in one layer of the image. And this is very useful for use cases when you have very small devices with not a lot of bandwidth. So when we created the Moby project back in April, the bet was that it would be a good fit for other types of container systems applied to different kind of use cases. And Balena to me was kind of the typical example of that approach working. So we start to see lots of people taking these components and building their own systems with it. Oh, another really interesting one was InfraKit. So InfraKit is our system for declarative infrastructure management. David, who's working on InfraKit, explained how he's going to... So InfraKit is all based on containers, and they can run in your Kubernetes cluster or your Docker Swarm cluster. He's building a horizontal pod autoscaler or infrastructure autoscaler for Kubernetes. So you could have your Kubernetes cluster when it's overloaded, the InfraKit component is just going to create VMs dynamically and add new worker nodes to Kubernetes. And when the pressure slows down, it can remove these nodes. So lots of super interesting talks at the Moby Summit. The last thing I wanted to talk about is we have another talk by one of my colleagues, Patrick. He has a talk this afternoon at 4:40, where he's going to go in the details of container orchestration, explaining when you should use Swarm, when you should use Kubernetes. And now with our platform, like you can use both. But he'll explain like which one is best for which type of use cases. So what I just showed you today, Kubernetes integrated in Docker. It will be generally available in Q1 2018, but you can sign up for the beta today. So you go to docker.com/Kubernetes, and the beta should be available in the next few weeks, for Docker for Mac and Windows as well as Docker Enterprise Edition. The GA version will be in Q1 2018. So that's it. I think I have a little bit of time for questions. Any questions? Okay. I hate to sit between you and food, so thank you very much for coming.